Hey guys, and welcome back to day 22 of our daily interview algorithm. So today we've got another algorithm that's based on code wars. This is called the genetic crossover algorithm. So basically, what you're given is you're given two strings of integers comprised of ones and zeros, and you're also given an index. And all you would need to do is for the two strings of integers is at the point of the index that you're given is to swap over the tail end of the strings. So here's an example. So you're given two strings here and an index. So that index would be 4. So 1, 2, 3, 4. Anything that's after that, you want to swap over with the second string of integers. So all you're doing is you're swapping them over and then you're returning them back. So here's a simpler example. You're given these two integers, two string integers here, and an index 3. So at this point here, you want to swap this tail end with this tail end here, and then return it. So the result would be 1 1 1 1 1 0, and then 0 0 0 0 0 0. And all we need to do is create a function that does that. So we're going to use a very simple way of solving this. Is we're going to use a substring of our first chromosome at the index, and then substring of the second chromosome from the index to the last index point, and then we're going to return that as well as the other way around. So from the first index to the cut point for chromosome 2, and then the tail end of chromosome 1 added on. So just to show you what that looks like, what I'm going to do is first create cross 1, which is going to be our substring of chromosome 1 first. So if we do chromosome 1 dot substring, and it's going to be at index point 0 to whatever the cut point is, and that's going to be for the first part. And then the second part is going to be the substring of chromosome 2. So we're going to do chromosome 2 dot substring, and that's going to be at wherever you cut up to wherever it ends, and that's going to be the length of it. But you can't just put in the length. What you need to do is you need to account for the fact that index 1 for the second part of the method overload is going to be wherever you start from here. So it's going to count incrementally. So what we need to do is, rather than passing in chromosome length, you need to pass in however many indexes it takes from this point here to the end. So all we need to do is actually pass in chromosome 2 dot length minus cut, and that should be okay. And then what we're going to do is, just to simplify our lives a bit, is we're just going to copy and paste this. And then if we bring this over here, so for cross 2, what we want to do is we're going to do the exact same thing but for chromosome 2, but instead we're going to add the second part, the tail bit of chromosome 1. And that should be okay. I don't know why we've got 3 there. I think that should be the cut point. Okay, and then the last step is we need to return it. So we're going to be returning type IEnumerable. So I'm just going to create an IEnumerable called result, and we need to initialize it with a concrete type. So I'm going to initialize it with a list, and we're going to be returning cross 1 and cross 2, and return result. Okay, so we're going to give that a quick test. And okay, so we passed the first test case, and then we're just going to run this. And Okay, so we passed all of our test cases. So all we need to do is, if you ever want to cross swap over any substrings of an index, all you need to do is just use this substring method and be careful about the overload. The first part of this method, it takes the index that you want to start with, and the second part takes how many indexes you want to go up by. So here we started at, here we started at the first index, where the first character is, and then we went up by however many times this cut was, so 3, 4, etc. So that was it, guys. Hope you enjoyed that one. So this was day 22. We've only got 3 days left, so stay tuned, and I'll see you guys in the next one. See ya.